Hello everyone and welcome back. My name is Sapna Parekh and welcome to this series where I will be discussing about topics related to data engineering, and in today's video I'm going to discuss about dimensional modeling. So what is dimensional modeling and how you build a data model that uses this technique of dimensional modeling. So let's get started. Yeah, so first of all, what is dimensional modeling? So you can consider that you have when you work with different sources of data as part of a data engineering team. So you have different data sources and you transfer that the data that is usable to you to your data warehouse. And the way you transfer the data to your data warehouse means you organize your data. So this technique that you use to organize your data is called dimensional modeling, and it was derived by Ralph Kimball. They have their data warehouse book as well. It's a really good book, and if you want to read a lot about data warehouse and understand in-depth knowledge about it, I would highly recommend that data warehouse book by Ralph Kimball. So but just to get started and have an overview, let's discuss over here. So this is a technique in which you organize your data in a data warehouse. So this is dimensional modeling is that technique, and it helps the analytical team to to aggregate that data in their data model, and when they have access they can understand the data easily using this dimensional model. So let's discuss about this in detail in the upcoming slides. So dimensional modeling helps with the improved query performance, and it makes the data understandable for the stakeholders. So it just makes your database you create your database using this technique, and it makes your database simple. So how do you design a dimension model? So first of all, when you are starting to build your data model, it's very important that you understand your data well. You know your data well. You understand like what is your business process, how your data is stored in what exactly like important columns mean in your data sources. So you understand your data well. Then you select the business process. Means it's generally like from the stakeholders, they come to you and provide you some use case and want some data from you, or some reports that could be generated from the data. So these are the different kind of asks that comes from the stakeholder, and so for that to answer them well, to provide them the relevant data in a you understand your business process. You select the business process, you understand that what will be the more relevant to your data solution. So for that, so business process is nothing but how, for example, if you work for an e-commerce website, so like customer logs in, search for data in a search bar, then place the order, add to the cart, and select some payment type, and then place the order. So this is an example of a business process. This is how business process looks like. So you understand that well, you select the business process, you identify the grain, you identify the facts, create the fact table, identify the dimensions, create the dimension table, and you use either star schema or mostly snowflake schema. Yeah, this is how you design your dimension model. So let's discuss all of these in detail in upcoming slides. So let's talk about how you select the business process. What is a business process? So for example, if a stakeholder comes to you and asks you for a use case or a business request that I want to do a year-over-year comparison of all the products that are listed in a particular category, and I am interested in how this product is behaving over the years. What is the sale? If sale has went up, gone down, how it is behaving. So So first you identify what is your business process, how your business works. So you like what are the data sources you have available for this data, and when you identify your data sources, you see, okay, what is the process? Okay, the user logs in, we have the user log data and their activity on the website. That can be like searching for the products with some keywords, and when they search for products with the keywords, what products are listed and what products are listed at the top, and what orders customer has placed an order for, added to the cart. And this is an example of a business process. And so when stakeholder comes to you, you identify what are the sources that will be relevant for your use case. Once you identify them, so you can see here, this is some e-commerce website. So you identify, okay, what are the tables that has product, sales, revenue. When you say the best products, it means like what are the products that are performing better, like whose sales has gone up, worst products which didn't do any sales. And then with this use case solution, you might provide like year over comparison, week over week comparison, month over month comparison. So we can solve all these problems using dimensional modeling. So let's see. So the next thing is you identify the grain. So once you have identified your business process, your data sources, you have understand your data well, then you identify the grain. What is grain? So grain is nothing but the level of detail, how you drill down the information in your databases. So every single row that you are going to add to your fact table helps you to define the grain of your data. So for example, see here I have placed an example. So suppose you can consider like this. Suppose if I tell you the sales of a region, what is the grain? It's the region that I'm. If I tell you the sales of a product by every state, if I go more below, like by city, by store, by customer, or something like that. So as I drill down below the information, the more atomic information I provide you, this is what the grain is. This is how you define the grain. So level of detail in your database, the atomic, and one more thing is the more the atomic your information is, means the more like more the information you are able to provide from your facts. You identify the grain and the more atomic your information is, the more analytics you could do on your data. So this is how you identify the grain, and it obviously depends on your source, the amount of information that your source is capturing, and then you will be able to identify your grain. So it is the granularity of your data, and it's very important you define it before finalizing your facts and dimensions, and it's very important you discuss the grain of your data with your stakeholders and come to a common solution, and then design your fact tables and dimension tables. So next is you identify the dimensions. Once you have finalized your grain, you identify the dimension. So you could think of a like cube where have different dimension, like time dimension, product dimension, if you are working for an e-commerce website. So there could be many possible, like store dimension, like region dimension. Suppose you could slice and dice your data based on these different dimensions. So this is what a dimension is. So dimension is something that helps you in your database to answer the questions like why something happened, what something happened, when it happened, where it happened, how it happened. And remember one thing, like every dimension has a primary key, and these primary key needs not to be derived from your sources. You can have it your own surrogate keys added to the dimension key. Surrogate keys are not something that is available in your source table. These are something you add to your dimension table, and every fact table associated with dimension has have that as a foreign key in its fact table. So examples of dimension looks like date, location, products. This is how. So dimension is mostly something that is descriptive, that we can use to measure the facts. So for example, suppose this is your database looks like. So what can be the dimension in that? Something that is descriptive, that is not something you can add up. So for example, product name. You cannot add the product names. Product ID. This is something that is unique to the product name. You cannot add this. It doesn't make any sense to add this. So this can be a dimension. Date is like, I have always used date as a dimension. So these are the things that you can use as a dimension in your tables. Then once you have finalized your grain, your dimensions, you go for facts. Like, what are the facts that you are going to add in your fact tables? So facts are something that you can measure. They are mostly numeric, and there are many types of facts, but mostly we will cover the three main types, that is additive, semi-additive, non-additive. Additive, obviously it's clear with the term that additive is something that you can add. For example, sales, you can add the sales. Semi-additive, something the table that has additive data, as well as something that you cannot add. For example, if you have some ratios in your table, some percentages, like if I add ratio or percentages, doesn't make any sense in the table. And then you have non-additive facts, that can be something like descriptive values. Obviously you cannot add that. So these are the different kind of fact tables based on your data sources, how your data is available in the source. You design your fact tables. So can nulls be in fact tables? Yeah, sometimes there are nulls present in the fact table, and fact tables using this dimension, like they handle these nulls very well. So it's always a good idea that for the null values in your fact table, you define something in your dimension table as not applicable, or something that is not available, or some value, some informative value that you can identify it's a null. So if you use that, it handles the nulls in your fact tables very well. Then there comes something as periodic snapshot fact. So these are the data in this kind of fact table is something that is not always readily available. It is something that is loaded, which is available like once in a day, or once in a month, or once in a year, or once in a week, something like that. So those we call them as periodic snapshot. So example of facts are something like in previous we saw, like these are units, unit price, cost price, something revenue, these kind of attributes, we define them as facts. So next, like here is an example of fact and dimension table. So when I have to design, I will define a fact table. So we use either star schema or snowflake schema. So I will be making another separate video on snowflake and star schema. But as of now, you can consider this is how the fact table look like. So I have defined one dimension table, a date dimension table, another product dimension table. I can add like some products, product key, and in date dimension date key, and different dates, month, year, all the date information will be there. And then I can have those like primary key added as a foreign key in my fact, and I have the fact. And then this table, I can use this table as a source. I can connect from my BI tools and aggregate these values based on my business use case and requirements. So this is how we works with the fact and dimension table. This is how we create a data model. In upcoming videos, I'll discuss about like snowflake schema and star schema in detail. Do let me know in the comment section if you have any doubts or questions, you want me to make some video related to data engineering topic. You can add that in comments. Thank you for watching this video. Thank you.